All right, this is section 1.4 for Algebra 2, writing linear equations. This should be another section that you probably have already talked about in Algebra 1 before, but they have you review it again because it's really important. The first thing that they talk about is slope-intercept form, and you've probably heard the equation y equals mx plus b before. M, if you can't see what it's saying here, m is the slope, kind of like what we talked about in section 1.3. And the B is representing the y-intercept. Okay, the y-intercept is where it intersects the y-axis. So like this dot right here on the line, that dot is the y-intercept, okay, and then the slope is the rise over the run. So they want us to, in example 5, write this equation in slope-intercept form. So I know it has to look like y equals mx plus b. And when I write slope-intercept form, what I'm going to do is I'm going to find what the slope is, and I'm going to find what that y-intercept is. Okay, the x and the y stay in there, but the slope and the y-intercept are what I need to fill into the equation. Okay, so for this line, I've got a dot on 0, negative 2. If you can't see that very well, go ahead and relabel him. 0, negative 2, and then this point over here is another point on my line that goes through perfectly. He is negative 4, negative 1. Okay, so I've got those 2 points. Now, if I'm trying to find the y-intercept, all I do is I look at the graph and see where is he touching that y-axis. The y-axis is this one straight up and down here. He is intersecting at negative 2, so that's all I do here is negative 2 in that spot for the y-intercept. Okay, and then when I'm looking at the slope, in section 1.3, we talked about an equation that was y2 minus y1 over x2 minus x1, okay? So we would use that equation to find the slope if I'm given these 2 points, or since I'm given the graph, I'm going to cheat and I'm just going to look at how much it's rising over how much it's running on this graph, okay? So if I look at, these 2 points right here that I've labeled, it is rising, it's actually going down 1 value, which means that my slope is going to be negative 1 over, it's running 4 units. So 1, 2, 3, 4, so negative 1/4. It's going down 1, and the run is 4 units, all right? So to make this a little bit nicer, I would write y equals negative 1/4 x, and then plus a negative 2. I don't really need both of those symbols in there. It would just be like minus 2, because a positive and a negative makes a negative. So this would be the equation of my line in slope-intercept form, okay? All right, that was the slope and the intercept right here. Negative 1/4 is the slope, and negative 2 is the intercept, okay? Now, this next piece in here, they do not have labeled, right? Slope-intercept form is not actually what they're talking about in this box here. This is actually called point slope form. Point slope form, okay? I do not care for point slope form a whole lot. I'm more of a fan of slope intercept form, but I'm warming up to point slope form. It's getting a little bit better for me. He's not my favorite, but we'll have to deal with each other, I guess. This is the equation that you use for point slope form, okay? And the reason, or the place that they get this equation is directly from here. M equals y2 minus y1 over x2 minus x1, okay? What they've done to create point slope form out of this guy is they've multiplied by x2 minus x1 over here to cross him out, multiplied by x2 minus x1 on this side. So the equation is y minus y1, or y2 minus y1, are kind of the same thing, equals m times x minus x1, okay, or x2 minus x1, all right? So that's where the point slope formula comes from. He is really nice to write equations when you know 1 point on a line. So I know that I have a line that goes through the point 6, negative 2. That means it's crossing through the point at 6, negative 2, and it has a slope of negative 4. So they want us to write the point slope form of a point going through 6, negative 2 with a slope of negative 4, okay? In here, in this equation, y stays y, and x stays as x. Kind of like up here in my slope-intercept form, y will stay the y value and x will stay the x value. You're just going to plug numbers in for all the other stuff. So I need to figure out what y1 is, what x1 is, and what m is. Okay, those three things I need to substitute something in for. So y minus the y-coordinate of the point that I have is -2. So I'm going to do y minus a -2, because it says y minus y1. y1 will be -2, equals m. My slope is -4, so that's what m is. -4 times x will stay himself, minus x1 is the x-coordinate that I'm given for my point, so -6. Okay, and he'll look just like that. All right. I don't really like this y minus a -2, so I'm going to change that to y plus 2, and I'm going to rewrite it so it looks a little nicer. Y plus 2 equals -4 times x minus 6. I'm just rewriting this because it looks a little sloppy on the other side. And this is your equation in point slope form. Okay. I don't like him a whole lot just because I can't really graph point slope form as easily as I can a slope intercept form up here. But you know, a lot of people use point slope form for different things. So that is point slope form. Your y is going to stay y, your x stays x, and you just substitute the values in for your y coordinate, your x coordinate, and your m. Okay? Now, in example 7, they want us to write an equation of the line passing through each pair of points. We're going to go back and we're going to write this in slope-intercept form because that's my favorite. Okay, so it doesn't tell us. I think in your homework assignment it will tell you which form it wants you to put it in. Most of the time when they give you 2 coordinate points, they want you to write it in slope-intercept form. So that's what we're going to do now. These 2 points are what I'm given for to write my equation. Okay, so in slope-intercept form, it's y equals mx plus b, and I said before that the 2 things that I need to find are m and b. Okay, and I'm always going to find m first. Okay, to find m, I'm going to use that y2 minus y1 over x2 minus x1 like I have up here. Okay, so I'm going to label these. This is my first x-coordinate. -2 is my first x-coordinate. 7 is my second, 7 is my first y-coordinate. 3 is my second x-coordinate, and -3 is my second y-coordinate, okay? So if I'm going to do y2 minus y1, that's like saying -3 minus 7, okay? Over my x2 minus x1, 3 minus a -2, okay? -3 minus 7 is -10, and 3 minus a -2 is like 3 plus 2. 3 plus 2 is 5, so my slope is -2. All right, now I'm going to run over into b a little bit here. Now I've got -2 is what my m is, so I've got y equals -2 x plus b, and the only thing I have left to find is what b is. Okay, to find b, you're going to take one of these points, and you get to choose. It doesn't matter which point you use. You can use -2, 7, or you can use 3, -3. If one of those looks better than the other one, you can use that, and it will give you the same b. I'm just going to choose the first one, -2 and 7. To find b, I'm going to plug -2 in for the x-coordinate, because that's what x is, -2, and I'm going to plug 7 in for y, okay? And then I'm going to solve. So 7 goes in for y, -2 goes in for x, and I still have my b the same. B stays the same, all right? And I'm going to simplify, so -2 times a -2 is a +4. If I subtract 4 from both sides, 7 minus 4 is 3, and 3 is what b is, okay? Now, I'm not done yet. Even though I've solved for b, I've done my last part here. I've got to put it all together in one equation. So I already have y equals negative 2x, and now I'm just going to put plus 3 on the end because that's what b is, and this is my final answer. That's what you want in the end, okay? That is your equation of your line, all right? For the time being, I am going to just skip part B. If you want an example of part, well, shoot, I shouldn't skip part B. Now we'll go ahead and do him because he's going to give you a problem. Yeah, so we'll do part B, but I'm going to do him down here. So my 2 points are 4, negative 7. I thought I was going to get away with not having to do so much work, but we can't. 4, negative 7, and 4, 6, okay? These are my 2 points that I have here, and I want to do the same procedure again. So y equals mx plus b, and I'm going to find m first. Always, always find m first. This is my first x-coordinate. 4 is my first x-coordinate. My first y-coordinate is negative 7. My second x-coordinate is 4. And my second y-coordinate is 6, okay? So if I'm doing y2 minus y1, I would do 6 minus a negative 7. Okay, that's y2 minus y1. x2 minus x1 is 4 minus 4. Okay, now 6 minus a negative 7 is like 6 plus 7, or 13, and 4 minus 4 is 0. Okay, when you have 13 over 0, you have something that is undefined. Okay? Because you can't divide by 0. So dividing by 0 is undefined. I'm going to flip back to the first page that I had. Right here. I talked to you on section 1.3 about slopes that were undefined. Those were going to be straight up and down lines, vertical lines, okay? If I graph the 2 points that I had, 4, negative 7, and 4, 6, 4, negative 7, 1, 2, 3, 4, negative 7 is going to be down here, and 4, 6 is up here. It's going to be a vertical line straight up and down that looks like this, okay? And vertical lines, if you look back at your notes from section 1.3, I had it written down here. A vertical line, his equation is going to be x equals wherever that's going through because it's crossing the x-axis. It's cutting the x-axis here. And this one just happens to be cutting it at the value of 4. So x equals 4 is my value. Its slope is undefined, but x equals 4 is the value. So you treat those problems like that where you have an undefined slope or a 0 slope. Here's what a 0 slope looks like. Okay? You treat those a little bit different than what you did in example A. Okay? All right, last example. I'm getting tired. Example H, write an equation. They want us to write an equation in slope-intercept form for the line that passes through the point 5, negative 6, and is perpendicular to the line with the equation negative 3 halves x plus 7. Okay? Now, over here in this box, it tells me what to do when it's perpendicular and what to do when it's parallel. You might remember this from Algebra 1, but we'll go over it again. If two lines are parallel, they have the same slope. Underline where it says same slope, okay? So if I wanted to know a line that was parallel to this one, the slope is negative 3 halves, he would also have to have a slope of negative 3 halves, okay? This one I want is perpendicular, and slopes that are perpendicular are negative reciprocals of one another, okay? Negative means it's the opposite symbol. So if this is negative 3 halves, I want it to be positive instead of negative. That's the negative part. And the reciprocal means I'm going to take 3 halves and I'm going to flip it. So 2/3. All right? So to write the equation of my line, I know the slope has to be 2/3 of my new line. Okay, my new line is going to be y equals mx plus b. And I've already decided that the m part of it has to be 2/3 because it's the negative reciprocal of negative 3 halves. So y equals 2/3 x plus b. Okay? And to find the b, just like I did in part A up above there, I'm going to plug numbers in for y and plug numbers in for x. The numbers come from 5, negative 6 up here. 5 is the x coordinate, so I'm going to plug 5 in for x, and negative 6 is the y coordinate, so I'm going to plug negative 6 in for y. All right, now, the biggest mistake I see algebra kids make is they want to use this 7 right here for something. The 7, you'd never, ever, 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 ever use that 7 ever, okay? The only reason I care about this equation at all is to get this number and figure out what my new slope is. So cross that 7 out and cross out any other slope that you have when it asks for a parallel or a perpendicular line. Cross that out. You don't need it. You only need the slope to figure out where your new slope is, okay? We're going to find a new b, okay? 7 isn't good enough, all right? We're going to plug in 5 in for x and negative 6 in for y. So this will look like negative 6 equals 2/3 times 5 plus b, all right? 2/3 times 5 is, oh my goodness, 10/3, 10 over 3, or 10 over 3 is like saying 3 1/3, so 3.3 repeating. I'm going to convert that to a decimal, so 3.3. If I subtract 3.3 from both sides, negative 6 minus 3.3 is negative 9.3. That's what b is, okay? I have just solved for b. Now, I'm not done yet because I'm going to rewrite my equation. So I've got over here y equals 2/3 x, and b is negative 9.3, so I'm going to write it like that. Okay, just like that. All right, and that is section 1-4. If by chance it asked me for a parallel line instead of a perpendicular line, I would start out with my equation saying y equals negative 3/2 x plus b. Because parallel lines, I use the same slope. So if this one's negative 3/2, I use negative 3/2. And then I'm going to do the same procedure again. I plug 5, negative 6 in for x and y and solve for b and get my new equation. This one wanted perpendicular, so we use 2/3 instead of negative 3/2. Okay? So that's the only difference. You might have a parallel one on your homework assignment, and that's section 1-4.